Sorry about that. Document camera seemed to have gotten disconnected. Alright, so we're on this example where we're trying to look at some sort of function that talks about the number of bacteria after T hours in some controlled laboratory. So what we want to do is we want to go ahead and understand what it is we're trying to say terminology-wise with these derivatives. So if we're trying to say what is the meaning of f prime of t and what are its units, remember the derivative is the rate of change of the function. So this is going to be f prime of t would be the change in bacteria over the change in time. So in other words, it is the rate of change of the number of bacteria at time t. Its units are going to be bacteria per hour. So if we then said that f prime of 5 equals 1,000, then that means that the rate of change of bacteria is 1,000 bacteria per hour at 5 hours. So we don't exactly know what f prime or what f of t looks like, but say this was our function f of t. So obviously we can't go ahead and start before 0 because we can't start before 0 hours. Let's say this is what's going on, and say 5 is somewhere here. What we're saying is that if we look at the slope of the line after 5 hours, the slope of the line is going to be 1,000. And so what that means is that if we continued to increase our number of bacteria per hour based on what it is at time t equals 5, then it's going to continue at a rate of 1,000 per hour. Maybe it's going to be more or less over time, but at that moment, that's the rate of change that we're looking at. So suppose there's an unlimited amount of space and nutrients for the bacteria. We want to go ahead and think about which would be larger, f prime of 5 or f prime of 10. So say that we have as much food, space, as we need for the bacteria. Do we think that we're going to get a greater rate of change at f prime of 5 or f prime of 10? So if we think about it, if we have unlimited resources, we'd expect f prime of 10 to be greater. And the reason for this is, say each bacteria is doing something to multiply, and it doesn't have to compete for resources at all, then that means more bacteria would lead to more reproduction. So larger number of bacteria would lead to more reproduction. However, if there was only a limited number of resources, it's hard to say, but we would probably expect f prime of 5 to be larger, if only because with more bacteria, they'll begin to run out of space and resources. So remember, when we're talking about f prime, we're not talking about the number of bacteria at a certain time. We're talking about what we expect the rate of change in the number of bacteria will be. So if we only have so many resources, it'll probably be a larger increase earlier on and begin to taper off as time continues.